Good day, I'm Fernando Manalo from ECE42, and for today's experiment slash summative assessment 2, it will be divided into two parts wherein the first part is for the display to be outputted on the serial monitor, while the second part is using a 16:2 LCD with I2C. And to start the experiment, the objectives of this experiment is to convert analog signal to digital value for the Arduino to process and to control the angular displacement of the servo motor using the potentiometer. For the equipment and materials, the required are a personal computer, Arduino microcontroller, a robotic arm, or in this case a servo motor, a potentiometer, USB cable, power supply, breadboard, alligator clips, and connecting wires. For the introduction, in this activity we will be going to control the joints of the robotic arm, or in this case the servo motor, using a potentiometer as sensor. We will configure the potentiometer into a voltage divider circuit and feed the signal pin to the Arduino to have a variable value as we rotate the knob of the potentiometer. And now I will explain my code for the part 1. For the part 1, this program controls the servo motor displacement using potentiometer and displays it at serial monitor. I use the servo.h library and set the servo to my servo, and the variables are used are pot pin, value, degree, and deg temp, which is a temporary degrees variable. And now to start the program, I attach the servo to pin 9 and start serial.begin and then serial.print servo motor control. And in this part, it reads the current value on the voltage divider circuit at the potentiometer and turns it to degrees using the map function, and then prints it to the serial monitor. For the next part, in the loop section, val equals analog read pot pin reads the value of the potentiometer, and this also maps the servo with the values from 0 to 180, and then the red value will be written on the servo using my servo.write degrees. And in this if statements, this is for the data acquirement, or the if statements displays the value and degrees at 20 degrees intervals. The serial.print prints the degrees, and then in this case I use degree is equals to deg temp plus 20, wherein deg temp is initialized to whatever the initial value of degree is, and then as the degree increases, if it equals to deg temp plus 20, meaning 20 degree interval, it prints, and also in this case it decreases. Now I will go to the actual circuit, or first we will upload it. Now it has finished uploading, and now we will open the serial monitor. And as you can see, if I rotate the knob, the servo moves, but it only increments the values here by 20, as we are stated to record by 20 degrees. And we can also turn it back. Now let us switch cameras and see the actual. For the actual demonstration of this part 1 of this experiment, as you can see, I opened the serial monitor, and here are the values earlier, and then to clear this, Let us open it again. And now we are at degree 0 and the analog value is 0, meaning the potentiometer is at the least from the counterclockwise and the servo motor is at 0 degrees. Now, I will demonstrate that if I turn this knob, it will record the value in the serial monitor and turn as you can see, it's being recorded by interval of 20 degrees and it is moving by. Now I can turn it back by rotating the knob and it returns to the degree of 0. The analog value is 1 because it is not a direct, it uses the map function and it is not a direct substitution. Therefore, from 0 to 5, the value is still around 0 and 20. From 0 to 29, I mean. Now, if I turn the knob again, and that demonstrated that my part 1 of the experiment is working properly. Now I will go to explain the code for part 2, which is using the LCD display 16:2. Now here's my code for the servo potentiometer and the display will be displayed at the LCD. So in this case, I use the liquid crystal underscore I2C.h for my library, which is available at the libraries, and wire.h for communication to the LCD. And then I set my LCD to, which is the address is 0x27. It is a 16:2 LCD. Here are the integers I used earlier, and I added, the only thing I added was in the void setup. In the void setup, I added LCD cursor, set cursor 1:0, which sets the cursor to character 1 on line 0, and then this moves the cursor to character 2 line 1. In the line 0 character 1, I added port value which will display at my LCD and angle at the lower bottom. And this void in this function is output serial LCD. I will explain that function. In the function, it prints the values in the serial monitor and it also prints it prints a space to clear the output of the LCD, and then prints the value of the potentiometer, a space again to clear the output of the angle, and then prints the angle with the character 223 for the degree symbol. And in the void loop, it's the same thing. It reads the analog at the pot pin, which is A0, and then maps it to the variable degree and then writes it to my servo motor pin number 9. And these are the if statements to display the outputs at 20 degrees intervals. The output serial LCD is the same as this one, which I explained earlier. And now I will switch cameras. I will first upload it. I already uploaded it, and then I will switch cameras and then show you the actual in the actual circuit. In this circuit, as you can see, after it initialized, it displayed the current value of the potentiometer and the current angle of the servo. And the only different in this connection is that I added the SDA and the clock and then I connected it to the 5 volts. And now I will move the potentiometer, and then we should see the servo motor move, and the value displayed here will be at an interval of 20 degrees. You can see it's 20 degrees and the servo is 20 degrees. Then I will turn it again, and you should see the servo move again, and the potentiometer value is now at 40 degrees and then 230, and the angle is 40 degrees. And then if we move it again, it's now at 60 degrees and 342, 80 degrees at 458, 100, 569, 120. As you can see, the servo is also moving. And 140 at 796, 160 at 910, and then 180 at 1023. And that concludes that, and we can also turn it back before we conclude. We can also turn it back. As you can see, angles are turning. And that concludes this experiment, wherein we are able to display the output at an LCD in this part, and the output is the potentiometer value which we are controlling and the angle of displacement of the servo motor. And that's the end of today's experiment, and thank you.